Hello everyone, and me and Jakob today will present about the usage of remote sensing engines for installation of photovoltaic solar panel. Here are the table contents of today's presentation: their objective, expected outcomes, details, execution, Appendix 1 PV system plan, and Appendix 2 pros and cons of PV. In here, we aim to use RS or remote sensing NG's technology to enhance feasibility of a small-scale PV solar system design plan. There are two expected outcomes from this. The first is using remote sensing NG's technology to find the optimum tilt angle for PV project, and using remote sensing NG's technology to find the best place to install the PV near plant vicinity, roof or open land. First of all, what is optimum tilt angle? Optimum tilt angle is the best angle for our PV to receive a direct light or beam radiation rather than the diffuse radiation. As I mentioned before, beam radiation is more of like a direct light. For instance, during the summer, where the sun is just above our head, so it's directly into us. And and diffuse radiation is uh, we can experience this during the most of the time during the winter times where the sun are the further away. And for the formula of finding optimum tilt angle, we can see here there the northern hemisphere formula and the southern hemisphere formula. Because we live in Japan, we will be using the northern hemisphere formula. So the panel will be facing south at an angle equal to the latitude. We add 15 degrees to the latitude for the winter and subtract 15 degrees for summer. And next, this is just an addition to another way to calculate the angle. Moreover, using remote sensing and GIS technology to find the best place to install the PV, as every PV system planning will be resulted in estimation for the number of solar panel needed. We need to think about the place where to place it. Thus, with remote sensing and GIS technology, we can then measure the area of the roof or empty land within the vicinity to choose the best location to install the PV. For the execution, finding the optimum tilt angle, we definitely use Google Earth in this case. We measure exact latitude of the place. As we can see from the picture below, the exact location of the place is latitude of 33 degree 18 minutes and 57 second north, longitude of 131 degree 29 minute 44 east, or in a decimal degree is 33 degree for latitude and 131 degree for longitude. As the location located in northern hemisphere, uh, then to find the optimum tilt angle, we need to set the panel facing south at an angle equal to the latitude. In addition, we can add 15 degrees to the latitude for the winter and subtract 15 degrees to the latitude for summer. Therefore, the optimum tilt angle would be 33 degree in general, 48 degree in winter, and 18 degree in summer. Here are the photo of the direction and angle of installation as we mentioned before.
Okay, now
Next, uh,
okay now we are going for the second expected outcomes, which is to choose the best location to install solar panel. So from the energy system plan, we received that we need a total of 6 solar panels, and here are the dimension of the solar panel. So if we arrange it, it will create this area, which is we needed 6 meter of width and 7.8 meter length. And using the Google Earth, so first for the roof, using the measurement features, we found that the width of the roof has around 6.67 meter, which is sufficient, and have the length of around 8.43, which is also sufficient. So we can totally plan the solar panel on the roof. But the cons is, as we can see, the roof shape is a triangle, and we can see from the compass, the south is facing this way. So other side of the roof may have require additional transformation to make sure the panel achieve its optimum tilt angle. Because as mentioned before, the optimum tilt angle can be achieved if the solar panel facing south. And for the empty land, using the measurement features, the width have 7 meter, so it's just sufficient, and the length is more than 17 meter, which is more than sufficient to install the solar panel system. But the cons is because it's located on ground area, so there's a possibility that the sun would be blocked from the solar panel, and basically the solar panel will receive more diffuse radiation rather than beam radiation. So as a conclusion, based on like current data, we will choose the roof as the place of installation because in reason that it's much more higher ground, and there will be methods to resolve the problem of the angle of the roof and to receive the optimum tilt angle. But if there are another method affiliation to resolve the problem for the empty land, where we can basically trying to resolve the problem of the sun will be blocked, then we will decide which is the best. So these are the appendix. So I'm gonna share about the energy audit. So basically, this is what I learned during the break using one of the e-course from the course era. So to make the energy system plan, we need data of the most monthly basis of use electricity, and then what what kind of wattage that we need during emergency. And then afterwards, we measure the system size and we choose number of, and then we can count number of panels that we need to plan. So this is where we found out about the area and the number of it. These are the formula. Then afterwards, this is like the required inverter size, basically using the data from before, the maximum and the wattage needed, and then the battery bank, what are the battery needed. So this is the budget, basically from the previous data. We need to buy this kind of uh, components, and this is all available in database like internet. You can order it on Amazon and so on, or like the official page. So this is the final system setup with estimated budget of 2000 yen. We can plan the solar panel for the share house. So these are the pros and cons of PV just for your guys knowledge. And we believe that uh, it, we need more renewable energy because it's more sustainable and clean and less life cycle costs. Even though it has large upfront costs, but it would be beneficial for the latter. So thank you for listening to our presentation. Is there any question? We would like to receive it.